Right, I'll start again. Thank you. Good morning for those of you joining from the Americas. Good afternoon for those joining from the European time zone, and good evening for those of you brave enough to join us from Asia. We've got a good lineup today, both in terms of speakers and excellent group of panelists who are going to tackle the topic of pursuing hyperscale economics, and in particular, what's the role of disaggregation and cloud native in that pursuit. So we're just waiting maybe for a few more attendees to join in, and then we'll kick things off. I think we might give them just a few more minutes. But without further ado, I'll introduce myself. I'm Phil Laidler. I'm the director of the consulting at STL Partners, and I'm going to be your host for today's session. We're going to run through some of the logistics and then we'll kick off on the presentation. So those of you who are not familiar with GoToWebinar, there is a panel which you can use. You're all in listen-only mode. If you'd like to type a comment, please do so. We are going to have a Q&A session at the end of the panel. So any questions you've got for the presenters, for the panelists, please put them in, and we will do our best to process them and to answer them today. Those that we're not able to answer today, we'll try and answer after webinar. We will be sending everybody who participates and joins today copies of the slides and the recording. So no need for you to take screenshots, any of that. We'll be getting that. Right, I think we are sort of getting there in terms of attendees. So what I'm going to do while we wait for the last few people to join us is kick off and introduce the presenters for the next session. So what the folks today is going to be obviously myself, my colleagues Yasmin and Miran will present the findings from our recent research into the topic. They will be followed by a presentation from Judy Cohen from DriveNets, sharing DriveNets' experience of sort of introducing hyperscale economics to operators. And then we're going to have a panel session where we'll be joined by Bryce Mitchell from Rogers Communications, by Joe Beimel from KGP Co, a systems integrator that specializes in introducing cloud native networking to clients, and by Inbar Lasarab from DriveNets. So that's the lineup for the folks today. And I think we've got nearly those who are going to be taking part joined us. So I'm going to ask my colleagues Yasmin and Miran to kick off and share the results from our recent study into hyperscale economics. Over to you, Yasmin.
Fab, thanks, Phil. So yeah, as Phil said, we're going to be talking a little bit about our research into hyperscale economics and where disaggregation and cloud native play a role within that. And this research is based off some interviews that we've been having over the past few months to talk to telecoms operators across the globe, mainly speaking to people within the technology and networking roles. And we will be publishing a report off the back of this that it's going to be published next week, so we can send it out to all of you in an email if you want to read more about our findings. And essentially what the purpose of the research program was is to try and understand how operators are pursuing hyperscale economics and what challenges they're facing along the way with that. So to summarize our 4 key findings at a very high level, and then we'll spend the rest of the presentation diving into each of these a bit deeper. The first one is that essentially hyperscale economics is a concept that seems to resonate with people. It does seem to speak to people, but in different ways depending on the role and the organization. We found that disaggregation and cloud native do play a really key role within hyperscale economics, both from a cost, capabilities, and revenue perspective. But this isn't something that all people feel is applicable to them, and some people see this as being something that's really just for those bigger companies that have more scale, or even for the internet giants. And finally, what we think is really that hyperscale economics is something that should be kept in mind as more of a North Star and something to work towards, as opposed to a set end state that people can work towards. So that was a very quick recap, and then we can dive into each of these findings a little bit more. So to start off with, it's helpful to explain what we actually mean when we talk about hyperscale economics. So a lot of people think that this is really just about scale and that ability to reach massive size and scale, and therefore it's only something that's achievable by the huge companies like the big internet players, the Amazons, the Googles of the world. But we see some hyperscale economics as actually being about detaching the cost base from the ability to scale. So you can essentially separate the rate at which your capabilities grow in comparison to how your cost base is growing as a result. And that means either your capabilities can grow exponentially with a linear or flat cost base, or the capabilities can grow in a linear way while the costs fall exponentially. And therefore, it's not something that only the internet giants should be able to achieve, but in theory, something that can be pursued regardless of the organization. And it's worth also noting that capabilities doesn't necessarily equate directly to revenues. So some essential capabilities include the ability to add more capacity without having to increase your costs at the same rate, whereas other capabilities are more directly related to the revenue generation, for example, the ability to provide new over-the-top or network-enabled services. And so there's a variety of key drivers for why telcos are pursuing hyperscale economics. We've pulled out 4 of the key ones. So in terms of the scalability, obviously operators need to be able to deal with flexible demand and scale up and down their networks in order to meet those changes in demand. And they want to be able to do it in a way that doesn't always require the costs to be increasing at the same rate. So hyperscale economics offers a way to expand capabilities in a way that really optimizes resources so that you're not having to invest in increasing your capacity to accommodate a sudden spike in traffic and then ending up with a lot of underutilized hardware. It also enables faster innovation. So a lot of operators are really interested in the hyperscalers, not just as a model that they can learn from in terms of technology, but also in terms of their ability to really maintain that small startup-like agile practices and the operating models that have allowed the hyperscalers to stay agile despite their large size. And so a lot of what hyperscale economics is about is that ability to accelerate the rate of innovation and the speed at which telcos can grow new revenue streams. The next one is flexibility and optionality. So a lot of interviews emphasize that need to scale without having to compromise on flexibility, because a lot of the time, increasing the throughput can be at the expense of flexibility. And also a lot of the ways that some telcos interpret flexibility is around that need to become more vendor agnostic and infrastructure agnostic. And then finally, resilience to shocks as well. So some of the telcos we spoke to said that hyperscale economics for them is really about that robustness and the ability to sustain shocks better, whether that be something internal, an internal failure, or an external market impact like a new competitor. So we're now going to have a quick poll just to try and capture your initial thoughts in terms of whether or not you think that hyperscale economics is something that is achievable by telecoms operators. So hopefully this should be showing up for all of you and you should be able to pick an option. The first one is that no, you don't think that this is really something that's applicable. It's a bit of a fantasy, but ultimately telcos are just too different to the hyperscalers for this to really be relevant and applicable to them. The second point is saying, yeah, sure, there are parts of this that are relevant, maybe relevant to particular parts of the business, like agile practices within IT, but it's not fully an achievable concept. The third one is, yeah, we can do this, but only the bigger operators, realistically. For me as a smaller operator, it's not going to work. And then finally, the most optimistic one is, yes, we can do this, and this is something that any telco can achieve. So hopefully everyone's voting away. Definitely interested to understand your views. And then I think once everyone's voted, we should be able to see the results on the screen. Are the results showing?
Yep. So quite interesting here. We have 38% who voted in part. So some of the concepts are relevant to some telcos. We then have 33% saying yes, but only a few operators can achieve this. And then actually, up to a quarter, so 23%, who said yes, it is something that any telco can achieve. Interesting.
Okay, so a little bit of cautious optimism, maybe. So if we dive into a bit more about how telcos can actually go about and become that 23% that actually can achieve hyperscale economics. So we did find a pretty general consensus amongst all of our interviewees that moving to cloud native and to a more disaggregated model within telco networks can enable hyperscale economics. And just to clarify, when we talk about disaggregation, obviously there's a lot of different levels to this. At the most basic level, it's just decoupling that hardware and software, or you could go even further and break it down into more granular levels. But at a fundamental, when we talk about disaggregation, we're talking about the ability to separate the network into the different elements or functional components, and so they can then evolve independently of each other. And what that means is that you can make changes and swap out components without impacting the others, which enables you to achieve best of breed, and that promises much greater choice of solutions for telcos, greater competition within the vendor ecosystem, and it brings back more control to telcos. And it also enhances their ability to innovate because they're not tied to a single vendor and they do have that more layered architecture, so they're able to act more flexibly and innovate and launch services more quickly. And then finally, disaggregation also provides a greater opportunity for network automation. And we all know operators have struggled a fair bit in the past with automation due to data silos and proprietary network management tools and systems from very vertically integrated stacks. And so with network disaggregation, you're really able to improve and simplify the automation and management across the entire end-to-end delivery lifecycle, because it's introducing more programmable and open underlying infrastructure and software components with open APIs and greater abstraction within the network. So there's a lot of good things to come from disaggregation, and it can play a really key role in pursuing this goal of hyperscale economics, but it does also present challenges. It's not all easy. So one of those is that it does increasingly make it harder to place accountability because you're integrating multiple solutions from multiple vendors. It's a lot harder to define who's accountable for any errors, and you lose that one single neck to choke. It's also a challenge in terms of the internal skill set that you need to manage that technology and to deal with all of the different components and to deal with the integration of those. And a lot of operators just feel like they don't have the skill sets internally, and so there would have to be a big effort to either upskill their employees or recruit new employees. And then finally, change can be tough and people can resist it sometimes, and particularly with a more agile model, change is supposed to be a lot more frequent, and that's a big shift away from how telcos are doing things today and can be quite a daunting challenge. So Yasmin will go into more detail about how some telcos really see this increase in change and innovation as actually quite an intimidating prospect.
Thanks, Maren. So as Mira mentioned, so although most telcos do see the value in the concept of hyperscale and the need, not all, we saw in the poll, not all telcos think that it's applicable or achievable to them, whether it's to do with the technology that enables it, as we mentioned, a disaggregated cloud-native architecture for networking, or whether it's also the practices and the operational models, the skills, the culture. And we found contrasting perspectives on this. So we created, I guess, a high-level overview of the different types of operator groups that we see. In the first group, in the first two groups, we see change as the new normal. So Maren, if you just click through, they see hyperscale economics as the goal. So with disaggregation and cloud native as inevitable and the way that the industry is moving. On the far left, you have leading pioneers who are spearheading the efforts to achieve this, which includes, for example, taking a DIY approach, i.e. assembling or reassembling disaggregated components, taking on the integration elements, and also essentially leading collaboration efforts within the industry with vendors and other operators to create blueprints for others to adopt. You then have the avid believers who also see change as part of the transformation rather than the barrier, but again, maybe more reliant on blueprints and forums to sort of pave the way. And then we see what we call the cautious pragmatists and the what we call the constrained followers. So for such operators, change is seen as a bit more of a challenge. And so the cautious pragmatists still see the value of this concept and do see cloud native disaggregation as inevitable, but are more taking a more pragmatic approach and still see value in working with incumbent vendors to innovate and evolve at a speed that they're more comfortable with. And then you have the constrained followers who often see, for example, their current skill set or capabilities as a major barrier and therefore rely on their vendor partners to innovate on that front. And so often don't see hyperscale economics as achievable for them. And so we've heard a few different approaches now, and I'm keen to actually look to our audience to see how you think operators should and can realistically pursue hyperscale economics and move to that disaggregated cloud native model. Is it by adopting, as I mentioned, this DIY approach? Note, this is not about writing your own code, but it's more about assembling and reassembling disaggregated components, managing those CI/CD processes, etc. Or is it by leveraging existing collaboration efforts to and blueprints? Or is it by outsourcing more of the networking to the hyperscale cloud providers? Or if number 4, do you think the system is not broken and don't see the need for change for the status quo? Or as I mentioned, we mentioned previously in the poll, do you think the idea of detaching the way that your capability and costs change is unachievable regardless of what you do? So keen to see your thoughts. Seeing lots of votes now. So just to recap, the first is about adopting a DIY approach of reassembling and assembling disaggregated components, taking on that integration capability and building those skills internally. Or number 2, is it about blueprints and forums and standards? Or number 3, is it about outsourcing the networking to the hyperscale cloud providers for their cloud platforms, their capabilities and tool sets? Or number 4 or 5, not possible, or the current system isn't broken, therefore we don't have to change. Just seeing the votes come in. There we go. Interesting. So we see that over half of our audience think that these industry efforts, for example, blueprints, forums, and standards play a really important role. Interesting as well to see a quarter of the audience vote for number 1, adopting sort of the cloud native practices with the more DIY approach as the way to pursue this model. Really interesting to see that. And we'll dive into this a little bit more in our panel discussion. So back to the presentation. So the process of detaching your capabilities and cost base, as we mentioned, is not about a single breakthrough. It's more about an ongoing pursuit, and these come in different forms in different parts of the network. And we mentioned the shift to cloud native and disaggregation is taking place across all network domains, whether it is the core network, fiber access, or even the radio access network, albeit a little bit slower. In general, we identify sort of 3 key waves which are happening at different stages across different domains. So the first is about decoupling hardware and software. So moving away from dedicated hardware appliances to more generic commoditized hardware. And this is fundamentally about enabling telcos to standardize the management tools across hardware and to create more operational uniformity across different vendors for that control and management and operation of the network. And so it means that a lot of the innovation is happening much so on the software layer rather than the innovation. And the second is about the abstraction and disaggregation of software components to enable more of that software-based innovation. So this is about, as we talked earlier, about creating more infrastructure agnostic services. So you can change and evolve each building block without impacting the others, and developing open interfaces between the software components to avoid sort of monolithic systems that constrain innovation. And so with this more infrastructure agnostic nature, you can then unlock different types of operating models between the infrastructure and the services businesses to enable them to coexist in a much more autonomous but harmonious way, and enable each part to pursue opportunities independently, and also to, I guess, accelerate the beat rate of innovation, particularly for the services business. And the last is something that Maren touched upon earlier as well, which is about automation. And disaggregation and cloud native play a huge role in this, because with more open interfaces between software components and more common APIs, telcos can change the way that they assure and operate and manage their networks without being inhibited by proprietary network management systems, without operational silos. And with true disaggregation and greater automation, it then becomes much easier to manage multi-tenancy cloud networks. So, i.e. networks that share underlying resources, which means that as a concept of hyperscale economics, you can then address challenges with peaks and troughs in demand, and it means that you can expand capabilities in a way that optimizes resource utilization and cost efficiency. And so in terms of these breakthrough opportunities, and given the progress to cloud native in the core network, we actually see the core transport, in particular the user plane functions, as a key area where we observe more of an inflection point due to continued growth in traffic volumes, maturity of the ecosystem, a lot of learnings as well from the first wave of NFV, now with the deployment of 5G standalone cores and more, I guess, network convergence and consolidation. This is seen as quite a key sort of opportunity area here as well. So sort of just to wrap up our presentation, we have sort of 3 key recommendations at a more sort of strategic level for business leaders within operators and other key decision makers. Number 1 is about sort of the focus on the economics part of hyperscale, not just in terms of that size. It is looking at it as more of the goal and the basis to sort of realign company stakeholders and use that as a measure by which different initiatives are measured against. Number 2 is using this as a concept of challenging teams to deliver against that, with, I guess, disaggregation and cloud native as a means of achieving or pursuing hyperscale economics. And as we mentioned, identifying the key stages or breakthroughs in sight and the low-hanging fruit to build that momentum. And then finally, to more of the business leaders, drive this within your organization and build that conviction as a leader that your organization is facing in order to respond much better to the competitive environment, to respond to market dynamics, and communicate that vision clearly within the organization to drive that change. And with that, I'll hand it back over to Phil.
Thank you very much, Yasmin and Miriam, for that overview. And as we say, we are it's all written up in a report that we're going to publish next week, and we will be sharing that with you. I'd like to now invite Julie Cohen from DriveNets to take us through some of DriveNets' experience of working with operators to introduce hyperscale economics, or the disaggregation that we've discussed that. So over to you, Julie.
Thank you, everyone, and hi again. So we've established the understanding that operators wish to pursue hyperscale economics. We also established the understanding that in order to do that, they need to adopt a disaggregated cloud-native architecture for their infrastructure. But is there a right and a wrong way to do that? And this is what I want to touch in the next few minutes, because when it comes to networking, and specifically when it comes to the data plane part of networking, there is a right and a wrong way to pursue hyperscale economics and to introduce cloud-native disaggregation into your networks. And just a couple of examples, recent examples that were all over the news. Recently, AT&T decided to take their 5G core technology and implementation and push it towards the Microsoft Azure platform, the public cloud platform for Microsoft. Similar move was done by Dish, partnering with AWS in order to introduce disaggregated 5G solutions. And this is fine because when it comes to control plane, when it comes to the control plane functions of networks, which are basically compute resource savvy, this is something you can put on any machine that runs an x86 processor. It could be a server, it could be a virtualized server, and it could be a cloud instance running in your premise or out there in the public cloud. But when it comes to the data plane, when it comes to those functions in a network that should handle massive amount of capacity and traffic, there is another way to do it. Because if you put the data plane functions on servers like everyone tried to do a couple of decades ago, moving from PNF to VNFs, moving from the physical network functions, router and appliances, and dedicated hardware, towards an open and disaggregated network function on a server approach, it became evident then that when you do this, this becomes a scalability issue. And when you start to push more and more traffic towards your network functions, you need more and more servers, and this spirals out of control. So VNF failed in that respect. The next phase was moving towards CNF, towards cloud native architecture that resolved some of the scaling issues of VNFs. That means the geo scalability, the fact that you can deploy your network functions anywhere in terms of geography and sites in which you have a cloud presence. This was a big step forward, and we see that lately more and more operators are adopting this cloud infrastructure in order to pursue hyperscale economics. But as I mentioned, when you do data plane, when you do user plane functions on cloud native, public cloud architectures, which are based on compute resources, there is a big scalability issues because CPUs were not designed to handle I/O tasks, were not designed to handle a large amount of traffic, and the resources in servers or in cloud instances are very fastly exhausted when you run user plane functions on top of it. And this is why when it comes to data plane, you need to go an extra mile and to introduce NCNF. That's the network cloud network functions, which is the same concept as cloud, but the underlying hardware infrastructure is networking optimized. Those are white boxes that on top of the CPUs and the compute resources, they also have NPU resources, networking processing unit, dedicated ASICs that can handle a large amount of traffic very efficiently. And this is exactly what DriveNets does. DriveNets took the concept of cloud infrastructure of the cloud architecture and migrated it into the network domain. We build networks like cloud. That means that we use the same concept as cloud, with network, with hardware virtualization, with a cloud native software, and with open platforms, but we use and we virtualize platforms that are networking optimized. So we don't just take servers and put network functions on top of those. We take white boxes that are networking optimized, but still commercial off-the-shelf merchant silicon white boxes, and we virtualize them towards the application layer. And with that, we accomplish three goals on behalf of our customers, on behalf of you, the operators. One, we reduce the cost. We allow you to use commercial off-the-shelf hardware instead of monolithic proprietary hardware. We allow you to break the vendor locking. We allow you to have less hardware in order to serve the same amount of features, functions, and subscribers in your network. So we take care of the cost structure. We also allow you to have optimal scaling. We also allow you to mitigate the need for additional hardware, additional resources in your network in order to follow the growing demand for capacity, which is driven by new access technology and over-the-top services, etc., etc. This is because we use very simple building blocks and very granular scalability. So basically, you can build any size and any type of network site from basic building blocks, and you can upgrade and scale your network only in the plane you need to. You can scale your port forwarding, you can scale your packet forwarding, you can scale your fabric, you can scale your control plane separately from each other, and this gives you optimal scaling. And last but not least, like Miran mentioned earlier, we allow you to have ease of innovation. Software-based and software-paced innovation means that in order to introduce new service in your network, new service that will allow you to create new revenue streams and approach new customer base, you do not need to send hardware, you do not need to dispatch crews to the different sites in your network. You simply have to add a software instance on top of the existing infrastructure in your network. And this is very fast, very cost efficient, and of course bring you very short time to market and time to revenue. But how do we do that? So basically we take the basic approach of disaggregation, separate hardware from software, use commercial off-the-shelf hardware, and use software instances that build the network functions on top of it. But more than that, in order to use the basic building blocks, only few building blocks instead of very wide variety of hardware types in your network, we do something we call distribution. We create a cluster and group a bunch of white boxes together into a shared pool of resources. So you might have multiple white boxes, few or tens of white boxes in a single site, but all of them will act as a single hardware resource. And this is very important because it allows you to build any size of router out of just a couple of basic building blocks. On top of that, we do containerization. That means that we build networks like cloud. We put multiple instances of network functions on top of this cluster, on top of the hardware. That means that you can build a very large infrastructure in terms of its capability, but it will not serve just one network function. It will serve multiple network functions that will each get its resources in terms of TCOM resources, networking resources, compute resources, etc., but leverage the synergy between the different applications. So we can run multiple applications over the same hardware and eventually need less hardware in your network. And last but not least, orchestration. This is a major issue because, as you've seen before, operators are sometimes hesitant to go to this length because they need to reshape their operational architecture. And what we do with orchestration is that we simplify the management of this very complicated infrastructure, and we allow the operators to make this transition in their own pace while they can still use the same methodologies and the same skill set they have today in the network, managing a totally new type of network. So if we look a bit closer into what we do, we simply took the router, the monolithic chassis that had a line card, a fabric engine, a control card, and some kind of chassis with a backplane and power source, etc., and we broke it into pieces. So we have one white box, the NCP, the Network Cloud Packet Forwarder, that does the line card role. We have another type of white box called the NCF, the Network Cloud Fabric, that does the fabric type. We have the NCC, the Network Cloud Control, that does the control card, and on top of all of those, we have the network functions. So basically, we have a white box or a hardware instance for each type or each functions within a chassis. What wraps them all together, or what is, you may call it the virtual chassis, is the orchestration. The orchestration wraps it all up and give you a chassis look and feel in the good sense of auto discovery, redundancy, high availability, and manageability of the entire thing, but without the constraints of the physical chassis, which is limiting you in terms of capacity and in terms of power feed, etc., etc. So this is what we do when it comes to the hardware-software breakup. Bear in mind that we do not only disaggregate hardware from software, we also disaggregate packet forwarding from fabric. So if you need more ports, you need to upgrade only one part of your network. If you need additional capacity in the fabric, you need to upgrade only that. There is no dependency between all the types of physical and virtual resources in your network. And if you look at it in a symbolic way, we take third-party white boxes and servers. Those are gathered into a shared pool of resources and then virtualized with our hypervisor, with our virtualization machine towards the upper layer instances, the upper layer applications. So everything, including compute resources, networking capabilities, TCOM resources, is virtualized toward the applications, and those applications can be from DriveNets. So if you want a router, a BGP router, ISIS router, a peering router, etc., you get a software instance that runs in a container from DriveNets. Alongside it, you can run a third-party application, for instance, a firewall or DDoS mitigation or DPI. These could coexist together over this shared pool of resources. And of course, on top of it, you have the orchestration system that brings you different views for different operating functions. You can manage the router, you can manage the security, you can manage the underlying infrastructure, and everything you need to see, you will see it as you used to. You can see it as a router, you can see it as a firewall. You will not see that this is a software instances that is taking resources from different parts of the clusters. And of course, on top of it, we have a node-bound interface for you to connect to an upper layer management system or OSS and BSS. And just to conclude, what we came up with is basically a unified infrastructure for all parts of your network. So you build up each site from the amount of white boxes that accumulate to the number of resources you need in this site, but still you have only two types of white boxes in your entire network. You have the virtualization layer in each site, and on top of it, you can run any function at any site. And this means, by the way, that if you need a new function at the site, if you need to add a service to your customers, like a firewall that will serve enterprise customers, you don't need to dispatch hardware and crews into the sites. You simply add a container on your already existing hardware infrastructure and create a new service in a click of a button. So this was my part. Thank you for listening, and back to you.
Thank you very much, Jody, for that overview and an update. Interestingly, these aren't just theoretical concepts; these are real deployments to scale that DriveNets achieved. So it's good to have a view from what's actually happening. Now, I'd like to expand the conversation to our panelists and invite three more people to the existing presenters for our panel, and three illustrious panelists we have with us. First up, it's Bryce Mitchell, who's VP of Core Network Engineering at Rogers. And the great thing about Bryce is he doesn't just bring many years of experience within telecoms, but also some significant experience of working with cloud native applications outside of telecom. So he has that dual vision of the cloud native world as well as the telco world, and really looking forward to getting his views and perspectives. I'd also like to introduce Joe Beimel from KGP Co, who, if you don't know, are a systems integrator who've done a lot of work specifically around developing and aggregating network functions for operators, so sort of specialist systems integrator. He'll be able to share his experience of working with operators. And Inbar Lasser-Raab, who has significant experience, industry experience, many years experience, she can also share of introducing innovation in networking. So we've got some great guests here. What a crack on. Before I do that and start asking the panelists to respond to some of the polls and get their views, I just want to ask all of you online to submit any questions you've got, and we will submit those questions if we can today to the panelists. If we don't have time today, we will try and submit those questions and get you a response later on. So please, in your control panel, go ahead and submit any questions you have for the presenters or for our panelists. So first up, I'd like us to just quickly look at the poll again. The very first poll we had, I don't know if you could do that for us, Jake, share the results of the first poll, which was, to what extent is hyperscale economics achievable? And if you remember from the poll, we kind of, most people thought that this was realistic, and they thought that almost, it was not quite even split, a few more that the concepts were relevant, some that it was only relevant to a few, and then about a quarter thought it was relevant to everyone. So just coming back to our panelists now, I was wondering, Bryce, first of all, where would you have selected in the poll? And secondly, does this poll surprise you, or is this sort of what you'd expect?
Thanks, Phil. Yeah, a little bit. It does surprise me. I was hoping to see a little bit more optimism, but I'm glad that actually the one I picked was the same one that jumped out as the main one, which is in part but achievable. And I think the reason why I chose in part is because I think some of the concepts and some of the capabilities that hyperscalers have are developed to solve a different set of problems than maybe we're facing in the carrier space. So they may not be applicable to us, and that's fine. But I do think that there's a lot of value in these concepts. I think, as you mentioned earlier, and you showed those cost curves, it's one thing that we really have to do as an industry. Subscriber counts are kind of growing relatively flatly, but usage is going up quite a bit. ARPU is rather stagnant, and so we have to look at our cost structures and get them down. So we really have an obligation to bring these economics to bear to our industry, but I think that only parts of it are applicable. The things that I think that hyperscalers do that maybe aren't as applicable to the carriers at the end of the day, to the telco world, is around a lot of the really fast feature development that happens in that space. When I worked in a different industry, one of the big values we got out of this was the ability to mock a feature up, create it, put it out into production almost instantaneously, get some feedback and adjust as we go. I think the telecommunication space is a little bit more static than that. We don't have as much need to innovate on that fine grain of a level, since we're much larger in terms of our scope and our impact and things like that. So that's why I chose that one at the end of the day. But I really do think that there's a lot of goodness that comes from hyperscale concepts and economics that the telcos can benefit from. And I do think that we'll get there. I think it's just a matter of maturing the technology, adapting it to our industry, to the number of players that we have in place. It's not a simple one company doing software development for all its features. We have multiple different areas and operators all in play. So I think we'll get there, and we'll get to the value that we need out of this space. It's just going to take some time for that to distribute out across the industry.
Thank you very much for that and sharing those thoughts, Bryce. And I'm just conscious of time, so I'd like to move on. Actually, Inbar, you've got many years' experience, even prior to working at DriveNets. What would you say you've noticed as a big change within operators' thinking in how they build and run their core networks over the last couple of years? What would you say you've noticed?
I'll answer that in a second. I just want to add on what Bryce was just saying. I really connected with what you were saying, Bryce. I think the full aspects of hyperscale economics, nobody can achieve, or maybe few very large telcos will achieve, because it's the multiple aspects. But as Bryce said, when we do customer events or advisory boards, the #1 request is to lower costs. As you said, ARPUs are flat, and lowering cost is the big challenge. And with the hyperscale economics, with the model of disaggregation, you can achieve it in different levels. You can just go to standardized hardware. Then you can look at multi-service and virtualizing, maybe peering and aggregation network over the same infrastructure. You gain more economic benefits. Then what you said, Bryce, marketplace and ability to roll out new services or even third-party services and testing if customers like them and decide whether to keep them or not. That's kind of the nirvana. That's kind of the ultimate level of kind of faceted economic value from the hyperscale model. So I think that's why maybe some voted some and some voted others, but the idea is nobody can see themselves achieving everything up front. It's going to be phased, and starting with lowering costs, maybe with disaggregation, standard hardware, then multi-routing capabilities over a single network, peering and aggregation, and maybe core, and then moving to the next level. So just wanted to kind of add to that. In terms of your question, Phil, I'm sorry for kidnapping my time. What are we kind of seeing over the past 2 years? I think, again, we're seeing that Bryce touched upon that. With COVID-19, a lot of there was a huge increase in traffic on broadband, but then enterprise networks weren't as used as before. And we saw that our customers, the service providers, starting to build more and more capacity over that broadband network, while they have some unused capacity over their enterprise network. And Bryce, I don't know if you guys have experienced that, but we've seen that. So you do a build out on one end, and then you have capacity on the other. And that's where the hyperscale economics, the disaggregation ability to run multiple networks in different SIs is going to help kind of service provider to do better usage of existing capacity and existing resources that they have. So we're seeing service providers starting to look at that. And I think COVID-19 was a point where kind of caused service provider to realize they need to look at that. The other thing is the way that Dudi started his conversation. We're seeing cloud providers walking into this space, if it's to run control plane payloads over the cloud, or what we're seeing with SD-WAN and other type of services, that the WAN of the cloud is becoming an alternative for enterprise services backbone. Because if you move more, you use more SD-WAN, or if you have direct cloud access, all of a sudden you use your enterprise network less than before. And I'm going to look if Bryce is nodding, but I think that was another aha moment for service provider to realize we need to look at things a bit differently. Cloud providers are a player here. They can be partners. They can also take away some business from us. How do we manage that we can grow our business, but also partner with those cloud providers? And I think that opened up some new dynamics in the industry. So Phil, to summarize, I think COVID-19 kind of put the spotlight on the fact that we have separate networks for separate services that don't scale well, but also the cloud walking into the scene, open new opportunities, but also new threats.
Great, thank you. So those are the key recent catalysts, and that's what's driving a lot of the traction and interest. I'd actually like to bring in Joe now. I know, Joe, you've been working with a lot of operators in helping them with the transition and evolution of their network. A lot of what we've heard is that there are some big challenges to do with pursuing those. To what extent do you think that these are the barriers and concerns versus part of the goal?
Yeah, I think a couple of areas to touch on. I think Dudi did a good job in his presentation with the evolution of kind of how the technology has really transcended over the last couple of years. You know, we've got the application now of standard infrastructure. So that was something we didn't have just a few years ago. So we have the concept, I think you talked about on the presentation, about the idea of a blueprint. So now we have the ready-made flat platforms that we can use to deploy. It's readily available, COTS hardware infrastructure that we're able to source from a number of suppliers. So that's an important piece of it. I think the other aspect from an operations, it is different. It's different than how the operators are working today. It's different technology, it's different vendors. So there's an evolution that they have to retrain, they have to become familiar. It's a different support model. They're going to pick up the phone and call somebody different. How they support a multi-vendor ecosystem is going to be a little bit different. So there's just a lot of learning and training that happens within the customer base as well. And really in the second, they call it day 2 or day 1 deployments of this infrastructure. That's also important. I think being able to have a clear leader, a single hand to shake, makes that disaggregation deployment that much easier for the operators to be able to consume. I think that's the other aspect that's important, is make it easily available, easily able to consume across all the different organizations within operators. I think that's also something that's been able to really break down the barriers deploying disaggregated solutions. And that's really happening across the board. As Inbar talked about, with COVID, we're seeing operators have to look at their networks holistically. There's changes in infrastructure at the core all the way out to the edge. And how do I adopt a disaggregated solution across the board is important. Drive down cost, as you know, as we all know, the bandwidth demand is increasing. How do we drive down cost across the entire infrastructure?
Okay, no, thanks for that, Joe. That's good for sharing and getting your view, as it were, from the field. I've got another question here for Bryce. We've heard a lot when we were interviewing the operators that, you know, this pursuit that the hyperscalers have for continuously optimizing, continuously changing, this sort of pressure to continuously evolve is slightly at odds with the operation teams within operators who are looking for stability and who are just sort of concerned that they've got a very exposed asset base that they're just trying to keep the lights on and running. Is that that tension between this need to drive change and this need to keep the lights on? You know, is that at odds? Does that create a real difficulty when you're exploring these kinds of solutions?
Yeah, it does, and I think part of it is actually cultural. To be honest with you, you know, as operators, we are quite rightly so obsessed about reliability and stability of our environments, and I think that's a huge value that we have in an area that we just can't lose focus on. Especially, you know, we've talked a bit about COVID-19 today. I think that's thrown it in sharp relief as well too. You know, we rely on connectivity for our lives at the moment, and every interaction that we do, whether it be work and personal. So yes, absolutely. That is, you know, central to what we have to do as operators. I think where the conflict comes in, and it's almost an unnecessary conflict, is that because these are such new concepts, because we're in such unfamiliar territory, the ability to make changes at extremely high speeds in production is frightening to some folks. It's kind of discordant from what they're used to. But if you have the right testing and guardrails and systems and software development practices wrapped around them, it actually can be the opposite. It can improve reliability by taking some of these concepts to bear. You can, instead of having a few small instances of something in production, you can have, you know, up to thousands of very isolated instances of it, and you can test software patches and feature updates and everything in a very controlled but real environment, and that can actually drive reliability up. You have to get over the mindset shift of very long testing and soaking periods and things like that. And I also think as cybersecurity threats become more and more prevalent in this world, particularly as we go more and more digital, that actually over time, the stability and reliability of the network could drop if we don't have the ability to patch things and resolve issues and close security gaps at a very, very high speed, while maintaining reliability and consistency across the network. So I think it's a cultural shift, but I actually think in the long term it can lead to a better solution in a much more reliable space for us all.
That's a great point.
Yeah.
I want to add to that, and I'll throw it over to Joe, because I think that's one of the criticism we get with disaggregation is that, hey, you need to show the reliability, it's a new solution, but what Bryce is saying, actually, it's designed to be more reliable because now we have microservices and containers, because we can patch. Well, it's not monolithic. We can patch one area, we can upgrade another, and it can be very dynamic. And I'm throwing it over to Joe, because you had a comment that when we work together, you actually showed that it's much faster when we do it with the disaggregation network. So I'll let you take it from here.
Yeah, I was just going to say, I mean, to Bryce's point, I agree, it's a cultural shift. And we've been working together with DriveNets for a number of years now and with a number of tier one operators, and we've seen it. It is an absolute different way of thinking, right? There is the idea of working more with your SI partners, working more with your ecosystem just to be able to consume a change. But it's happening, and we've been able to successfully deploy these networks to a couple of operators. And it takes time. It's not something that's going to happen overnight. It is a cultural shift. It's something that I think the leadership teams across the industry recognize the value, but it is something that's got to continue to push. And to Inbar's point, you are able to deploy the technology faster if you leverage your partner ecosystem, which is maybe a little different way of thinking. And it starts out, in the very, very beginning. When you think about adopting technology, when you think about re-architecting your network, when you think about deploying new vendors, new technology into your infrastructure, how can your SI partners, how can your ecosystem help? Whether it's the labs organization, the architectural engineering organizations of the operators, they've got to be able to evolve with it. But it absolutely can be successful and deployed a little bit faster than what we're seeing with standard OEM technology. We've seen it, the proof's out there. But I agree with Bryce, like you said.
What you're saying is that the perception and the concern and the instinctive sort of fear of moving away from a very stable operating model, it's understandable, but it's actually mistaken. And that's just about cultural and awareness and familiarity and building in and getting that confidence that actually this thing isn't more unstable, it's actually more stable if you do it in the way that Bryce says and you start to feel comfortable with the tools. So that's a great answer. I'm really sorry, we've had some really good questions sent in, and we haven't had time to go through them. I'm going to try and answer one here. There's a question, just see who it's from in a sec. I'm going to attempt to answer from Praveen. And Praveen asked the whole debate about private versus public cloud. And again, this is a point you alluded to, Inbar, about working with the hyperscalers. It's not or, and this is coming up more and more. Hyperscale economics, do we need them? How do we work with them? What is the best fit for the telco cloud? How do you see this space evolving and the different performance demands, intricate workloads handled by these networks? So I'm going to ask you each the same question. I know it keeps coming back. It's this private versus public. Do operators want to be doing this themselves? Do they want to be looking to the hyperscalers? Is it a bit of both? So I'll start with you, Mark, because you introduced this, but very briefly in the remaining 2 minutes, if you could answer that.
So I think it's both. There is no one model. It's whatever, every service provider has their own model. The last mile and the connectivity is going to come from the service providers, and then at the network edge or the edge cloud, whatever we want to call it, we're going to see more services involved. They can run in the cloud. So I think there is a good combination here where service providers can work with cloud, but it has to be a disaggregated multi-vendor environment. And I'll stop there.
Joe, would you add anything? I mean, I'm not sure if you're having to think about working with and integrating hyperscalers and what your experience is of trying to do that.
Yeah, I mean, it's obviously for a while now, operators have kind of started to experiment working with the hyperscalers and trying to figure out what that business model would look like. What do we want to hand off to them? What do they want to control? Where are the assets going to be deployed? Whose software gets put on what? Who controls the architecture? So it is, to Inbar's point, it's a matter of finding what is the right operational model. What do I want to support? And then do I want to open that up? If I hand things off to the hyperscalers, then they're going to want to share that across and generate revenue from that. So it's not just my network now. It could be a number of operators operating on that same infrastructure. So it really becomes a decision, and it's a RACI chart exercise. Who's going to control what to make that successful, to deliver the business model they're looking for.
So Bryce, last word to you on this question of the public versus private cloud.
Yes, Phil. I tend to lean towards the private, particularly, informed particularly by my experience here in Canada. So, as Canada, as you know, is almost a continent wide in terms of a country. It is a continent wide, and so for us, public cloud doesn't have the presence in Canada that we would need to actually put our network on it. For instance, in the West, most of it tends to be in the US in another country. And we can't really put, our core packet processing systems and things across the border. That just doesn't make sense. We also can't backhaul that traffic to the East where the physical presence is. It's over 3,000 kilometers, for instance, to the coast. Also doesn't make sense. And I also worry a little bit about having all of our eggs in one basket. If we have the telecom functions in public cloud and those public cloud systems run into trouble, you've got significant communications and infrastructure disruptions across an entire country. That's not a good place to be. As COVID-19 has taught us, this connectivity is really, really critical. So I prefer the separation, and that's mostly what has been deployed for us in this country with the carriers, just because of those considerations and aspects. Now, I do think there is a role for the public cloud providers to play. Their software stacks are exceptional, and there's also the edge computing in that larger ecosystem that comes into play. So almost aligning with Inbar, I think there's a bit of both in both worlds, but for the pure telecom applications, my vote's private.
Brilliant. And that's why Judy presented Network Cloud, where you have the NPUs and the CPU, and you could do it all privately in your network, but you build a network like a cloud, and it can be fully private. So that's where the flexibility of the model come into play.
Great. Look, thank you all panelists for what's been a great conversation. I think we could continue. Unfortunately, we have run out of time. Thank you to the presenters. Thank you, DriveNets, sponsored this event, and thank you all of you who've attended the webinar, those of you who've submitted questions. My apologies that we haven't been able to address them all. We will try and answer your questions offline and share the results with everyone. So thanks again, and have a good rest of the day.
Thank you.
Thank you. Take care now.
Thanks, everyone.
Thanks, everyone.
Take care.
Bye-bye.